Welcome to CrypSwing version 3. This is Aaron Bittman, software developer. Before I demonstrate the program, I'll just give a brief explanation. I expect that you probably haven't seen other versions of Crypt, but just in case you have, I'll mention that the biggest change since version 2 is this. The guess function. Now you can tell Crypt to take a guess, not only when it first loads a puzzle, but at any time you want. Also, this version uses a smaller dictionary file because that one generally gets better results. On the occasions when the bigger dictionary gets better results, those better results are just a few more clues that a human user can easily figure out him or herself. And furthermore, when a user is browsing candidate words, it can get tiring to wade through many uncommon words looking for the more likely ones. Also in version 3, I added an About button so that you know what version you're running. I should also explain that this is the version of Crypt which I wrote in Java. I call it CrypSwing because it uses swing classes. I wrote the other version of Crypt without the swing in the name in Python. So, with that explanation out of the way, let's get to the point. What is CrypSwing? Back in the 20th century, I enjoyed solving cryptograms in magazines like this one. Cryptograms are messages written in code. Specifically, they're encoded with a monoalphabetic substitution cipher. In other words, one letter in the English alphabet would be substituted with another letter or symbol. The message in code is called ciphertext. The plain English to which you translate the encoded message is called plaintext. So for instance, if a plaintext A is written as a ciphertext C, then a plaintext A will always be written as a C throughout the message. Of course, solving such problems with only a pencil can sometimes be difficult and tedious. When you guess that a ciphertext symbol represents a certain plaintext letter, you have to search the whole puzzle for all occurrences of that symbol to translate it to the plaintext letter. If you later change your mind, deciding that's not the plaintext letter you want to guess, you have to search the whole puzzle again to erase every occurrence of that plaintext letter you wrote. Obviously, that kind of task screams for a computer program to do the work for you. Furthermore, a computer can search quickly through a dictionary file and suggest to what plaintext words a ciphertext word might translate, based on whatever criteria you decide. So when I learn a new programming language and come up with projects for myself to get practice writing in that language, I often choose to write a program to help me solve cryptograms. I typically name this program Crypt, short for cryptogram. Maybe one day I'll write another version of the program, spell it C-R-I-P, and claim that it stands for Cipher Resolution Interface Program, or something clever like that. And I explained earlier why I call this version CrypSwing. Now, I've seen other cryptogram solving programs which are only text-based. They might try every possible solution for one word, and based on each of those solutions, try every possible solution for another word, and so on. That approach can often be a good beginning, but I find many such programs leave a lot to be desired. What if one of the words in the solution isn't in that program's dictionary file? What if another word that fits the pattern is in the dictionary, so the program takes a wrong turn? What if there are many possible solutions in which the words fit but don't make sense when put together? I feel the need for a human user to intuit what direction to take and to guide the program accordingly. And to help that human user do the job quickly and easily, I feel the need for a graphical user interface. So let's use it. First of all, I'll just mention that even if you don't want to bother typing up a whole puzzle on your computer, this program can still help you by searching individual words. You can simply hit the Solve Word button, and you'll get an interface to examine one ciphertext word. I can enter one here and now. and find all the words in the dictionary that fit that pattern by hitting the Solve button. I can search through these 65 results and try to guess which one is most likely, but there are ways of narrowing it down. For instance, I can check the like exclusion option. Like exclusion is my own personal term, meaning that a letter cannot translate to itself. For instance, a ciphertext A cannot translate to a plaintext A. Several people have pointed out to me that there's no rule that like exclusion must apply to a cryptogram. However, I've never seen a professionally published cryptogram that didn't conform to like exclusion, so I see no reason not to check it, especially when it can narrow down the possible answers. When I hit Solve, the program has narrowed the results down to 38 possible words. Another thing I can do to narrow down the possibilities is to tell the program that I know, or assume, that one certain ciphertext symbol translates to a certain plaintext letter. For instance, suppose that I've been working on the puzzle and decided that a ciphertext Y is an E in plaintext. I enter my plaintext E over the ciphertext Y and hit Solve. As you can see, that guess really narrowed it down. I should also mention, for those of you without experience in solving cryptograms, that when choosing a word to solve early, it obviously helps if that word is long, but something even more important is to find a word with many repeating letters. I'll demonstrate. I'll hit Clear to clear all the ciphertext and plaintext I entered, and enter even a short word with repeating letters. As you can see, even without like exclusion, I get a short list. So this single word solver window alone provides the heart of my program, but of course, Crypt can do more than that. And by the way, in case you were wondering about that Use Puzzle option, I'll get to that eventually. Right now it's useless because I haven't entered a puzzle yet. So let's enter a puzzle. Here's a file in which I typed up a few puzzles from an old cryptogram magazine. Now, a longer puzzle is generally easier to solve than a shorter one. A longer puzzle is more likely to have good starting clues and to have more useful cross-references to narrow down the possibilities even more. So I'll copy that long puzzle. Now, in my puzzle solver window, I'll hit Populate Puzzle and paste in the ciphertext. You'll notice that here too we have a like exclusion option, although I found that when Crypt makes its initial guesses, like exclusion doesn't help. So I'll just hit OK. As you can see, CrypSwing has solved almost the whole puzzle, leaving us just a little bit of work to do. It's obvious that S translates to D, so I'll just click on the plaintext space above any S. Now, when I hit the D key, Crypt will translate every S throughout the puzzle to a D, so that in more difficult puzzles I can instantly see what consequences my guesses would have. Well, in this case, they're not even guesses, they're obvious choices. So, for a real demonstration, let's try a harder puzzle. Uh-oh. Clearly, Crypt made some bad choices in its initial guesses here. This puzzle calls for human intervention. By the way, if I felt that only some of Crypt's choices were bad, I could just change the parts I dislike. For instance, if I thought the X should translate to an E, I could just enter an E here and CrypSwing will show me the consequences, but in this case it's obvious the solution was built wrong from the ground up. So I'll hit clear. By the way, notice that the bottom of the window gives us a frequency count of all the ciphertext letters, first in descending order of frequency, and then alphabetically. That can help us make guesses. Now, like I said, a longer word with repeating letters is a good starting point. So let's try this third word. If I click on any plain text space over that word and hit Solve Word, the single word solver window automatically populates with the ciphertext and any plain text that I guessed, although I can edit that information. I'll click Like Exclusion and Solve. And Crypt gives me 115 suggestions, some of which are more likely than others, as a human user would know. Even so, 115 is a lot. So let's try another word. Oh yeah, we can open multiple word windows at once so we can compare the results side by side. Now, what can Crypt do with this second word? There are 56 results. Which ones seem the most likely? Well, first of all, the three most common letters by far are A, U, and Z. So I'll guess that one of those is an E. Let's start with U. Most of these words seem unlikely. Let me try encourage. If I double-click on the word encourage, Crypt will immediately populate the puzzle window accordingly so I can immediately see the consequences. And I see that the second word has EOA in it. No way is that right. How about enjoyable? That looks unlikely, but let's try it. If I go back to the first word window and enter the EOB and hit solve, nothing. Exclusive? Let's try that. That gives us 5 possibilities. I could try them all, but maybe there's a faster way. After all, we're going under the assumption that the other word is exclusive. So we know, for example, that a ciphertext C is a plaintext S. Therefore, no other letter translates to an S. We could eliminate some words that way. I want to tell Crypt to account for the plaintext letters already accounted for by the other ciphertext letters in the puzzle. I can tell Crypt that by checking the Use Puzzle option. Ooh, there's only one word left. Let's try that. That looks promising. Let's see what we can guess for this word. It's all falling into place. Well, that was nice. but I just used some of those old features of Crypt to explain how to use them. For most puzzles I've tried, I don't need them. Version 3 gives us a faster, easier way, which I'll demonstrate. Now, if you watch my demo video of CrypSwing version 2, you'll see me working on this puzzle to demonstrate using multiple word windows and such, trying different combinations of translations for 2 words. I cracked the code in 4 minutes. Could I do faster? Let's try it now. Clearly, Crypt's first guess is wrong, but like I said earlier, we can select whichever clues we want. And that first word looks like never, doesn't it? It seems quite possible. The L is the second most popular ciphertext letter in the puzzle. So I'll hit clear and try never. Now, I could try some of those other ciphertext words one by one, but I want a faster way. I want to say, hey, Crypt, you know how you ventured to guess at the beginning? Well, I want you to do that again, only this time start with the premise that the letters I entered here are correct. I can tell Crypt to do that by hitting the guess button. Bam! Crypt instantly correctly solved the puzzle, except for one letter. Evidently, this dictionary file doesn't have the name Quentin in it. And if my guess had proven wrong, I could have guessed another translation or guessed some other letters altogether and let Crypt take it from there. And you can take it from here. Feel free to play with features. And here's a bonus. I provided a program to do the reverse. Generate a cryptogram from plain text you provide. I named it by spelling Crypt backwards and calling it Pyrc. Just paste a quote here. Run the program, and Pyrc will generate a cryptogram for you. You can create test cases this way. And there it is. Feel free to peruse my code and feel welcome to give me any feedback on GitHub.